So again, good morning. Just put on the screen there a little reminder of first information to update your calendar. We'll be going to we're going to have an in-person training on Wednesday, April the 9th there at the Sims building in Amarillo. So the topic is yet to be finalized, but it should be a good conversation. So it's going to be in the morning. So, and then while I'm in town, I'll also be reaching out to everybody, just kind of seeing if we can't do lunch or something, just to chit chat, see what's going on, see what best we can do to help make everybody's lives a little easier when it comes to energy code compliance. So I've also put into the chat the slides for today's class. If you have any questions, you can always download those and kind of keep. I know in some of our other trainings, people have really enjoyed having those a little early so they can take notes along the way. But we are going to today get into this concept of inspections associated with our air and vapor barriers. We've been talking about vapor barriers and air barriers, water resistant barriers for the last couple of weeks, kind of reinforcing the role from a design through plan review and now into the concept of installation and inspection. And so that's kind of the way we've kind of viewed it, and hopefully it's will be a good conversation for us today. So, and then I'll remind myself here in about 5 minutes to add that slide deck back into the chat just in case anybody shows up late. So if you've not already checked out the Excel website, the Excel does have a website available to you. If you need access to it, if you need that number, please let us know. We can always copy it and send it to you or share that link directly to you. There's going to be some changes to it to make it a little bit different, a little bit more responsive. But in that resource website, you should be able to find different technical resources, our newsletters, and what we've been calling our efficiency, our field verification guides, field guides for energy code compliance. And so we're going to use some of those today to kind of guide and help facilitate our conversation as it relates to the air barriers and vapor barriers that we see in a building. But, I always like to start off the conversation with this belief, this question, or the understanding, acknowledgement that when we understand the why behind a particular conversation, question, or component, we can better figure out the how we get it done. And that's the same, that's nowhere more recognizable than we talk about the water resistive air barrier and vapor barrier, vapor retarders that we see inside our buildings, right? We understand that at times the term barrier versus retarder are somewhat interchangeable, but we understand that what we're trying to do is control how a building operates, right? We understand the energy code is looking at it from that perspective of how do I effectively use and conserve energy over the useful life of a building. And to facilitate that, the code gives us a list of things that we should expect to see when we talk about buildings and energy code compliance. And that list has really been the same from 15 through 21 and into 24. The only thing that changes is in 21, we recognize the importance of specifically listing a compliance path. But in all three of those versions for the last decade, we've seen the role of the air barrier and air sealing details is one of those critical components that needs to be identified in a construction document, right? From the beginning. We've talked about this before. We talked about it last week. I have not found a contractor yet that's told me they maintain and always buying the latest version of the building code, right? They usually tell me, I know how to build, and what I'm going to do is I'm just going to build what's on the plans, which makes it even more recognizable why we need to have those plans from the beginning, identifying the appropriate materials and design expectations for those air barriers. Now we talk about the purpose of the barrier, right? We understand that certain barriers exist to resist or mitigate the impact of the exterior environment, right? That's why we have walls, roofs, and ceilings, is to keep the outside on the outside and the inside on the inside. And part of that relationship with that barrier is understanding, again, that what we're trying to control is not just the environment, right? The hot, the cool, but also the different types of environmental impacts like water. And we understand water comes in three different basic phases, right? Solid, gas, and liquid. And so when we think about that in relation to our air barrier is resisting that liquid for the most part. That water resistant barrier is resisting that liquid form, Our vapor retarder is resisting that gaseous form, and our air barrier is there to facilitate all of that. Sometimes serving as that component, right? That facilitating component. Now the building's thermal envelope is also that series of materials that exist to not just restrict the amount of to restrict the flow of conditioned space, right? It's that boundary that restricts and controls conditioned space in relation to unconditioned space, right? So just depending on the layout, depending on the design, you might have a series of building components that make that utilize those barriers different. Put it that way, right? So we may have a sunroom, right, where we have part of our building's exterior envelope extends all the way out to the end, right? We're protecting that sunroom, traditionally we'll call it, right? That summer season room, three season room from the rain and the impacts of the environment, but we're not conditioning it, right? So we might be keeping it more of a semi-heated or a semi-cooled space. And so we really need to identify where those barriers are going to be. And when we start talking about the relationship between the thermal envelope, the vapor barrier, the water resistant barrier, the air barrier, we need to always keep in our mind that air barrier cannot be an afterthought, right? We need to make sure we identify from the very beginning. I've been in a lot of classes and a lot of code development conversations the last couple of weeks, and all of those, invariably, those conversations, not me directing them, just if you listen to code development, right? And I work in a couple different states and monitor those processes, those conversations. Even the one where it comes up the most is in mechanical design, right? If we're going to pick the right piece of equipment for a project, design and think of those characteristics, we need to understand air control, airflow, right? We need to have a known air infiltration rate. We need to decide how much air are we bringing in and how much are we uncontrollably losing, right? And so air barriers are a critical component when we think about how much energy gets invested in the building, right? The insulation, the air barriers, the water resistant barriers are all a one-time upfront cost for the most part, right? Those are a one-time cost. The thing that really drives a property's efficiency over its useful life, right? The purpose of why we talk about them is really those mechanical systems, right? Those mechanical systems that operate and have to respond to changing dynamics. And so that air barrier may be a one-time shot, and so we need to do it right the first time. And so one thing we've talked about before, and we've reinforced that through our plan review courses and the design conversations, is compliance starts on paper, right? It all can start with this construction document, but that compliance requires us to go out and do an inspection, right? We don't expect our plans examiners, as great as they are not the ones who are going out and doing all of the inspection. Or when I, as an inspector and a plans examiner, sit in my office, I can't just say, well, I've designed it, I've reviewed, I didn't design it, let me rephrase that. I've reviewed it for code compliance. It must be perfect now, right? Nobody says that and actually means it, right? We all understand that we have to go out and actually verify that it's been installed properly. We do the same thing with cars and everything else. We do it with buildings. And so when we think about those things, we have to recognize that what we've done in design, what we've verified and planned, now becomes to us as inspectors to go out and accomplish and verify in the field with our installers. And this is part of that totality of the family, of the relation of the building safety community as a whole. So one of the things we've tried to put together is this series of different technical resources addressing the role of inspections. Now, this is not to be a guide and a do this and this is the solution to life for an inspector. What I tend to use this for is it's an assistive tool for me as an inspector, but I also tend to give this to my contractors so they know they can pre-check before I get there. Don't call me if you know that you got problems, right? I will. The reason you have to, and this is a little aside, right? The reason we have problems with scheduling inspections is because people call me thinking they need to schedule even though they're not ready. When you're ready, you call. That'll make my life easier. I don't have to drive all the way out here to find out that you weren't ready, and then I got to come back tomorrow and do the same thing. You've now wasted more time than it was worth, right? And so all the time, if we know if the contractor knows what I'm expecting to see, he knows when to call me, and that's what these field guides were designed to provide. Now, the guide was broken down into the 5 basic functions, or 4 different functions, right? The insulation, the air barrier, the mechanical systems, the power and lighting controls. Now, I'll be honest, when we're talking to 15, 18, those those lighting controls, super simple, right? But when we start to think about maybe as we move into the future, different future editions, they get a little bit more complicated. Or when we think about multifamily buildings or other things like that, they can get a little bit more complicated. Um, so one of the things that we see in that conversation is, again, this concept of the air barrier, and we'll talk about that as we go throughout the process. But we're inspecting for our building thermal, our energy code compliance. We normally jump. The first thing we think about is our building thermal envelope, and the same thing applies when we think about air barriers and vapor barriers. Now, the one thing I think is important for us to always reinforce is the role of energy compliance paths in identifying the level of flexibility when we do our inspections. Right? We know that if a project is following a prescriptive path, we know because of both whether they're following the table or using the UA, the res check, there's a level of flexibility there that may not be the same level of flexibility when they're using a performance measurement. When they're using an ERI or an Energy Star or something like that, they will incorporate, and I don't know if I've got a, let me see. Nope, it didn't include one, because I think the only one I had was commercial that showed it. But when they start to incorporate and think about those designs on those performance-based calculations, then that's when they start thinking about how much air is really going to be moved. And then that's when the mechanical equipments become more important to the discussion. And so you may find an ERI or a simulated or an Energy Star that says, this is the expectation for air control, and it's more than what we see in the traditional prescriptive process. And that's normal to see, but that just reinforces I, as an inspector, need to follow this plan to a T, because this plan, this design, this construction detail needs to be followed in order for it to meet its compliance path. I have flexibility in a prescriptive value, right? If I'm saying put in an R15, I give them the flexibility to decide, is that mineral wool or is that a spray foam, right? But when they're going to an ERI path and it says that we're using spray foam, and I've evaluated the design and plan review process, that spray foam is being used not only for thermal insulation, but also as part of an air barrier, I need to make sure it follows what it's doing. I can't say, well, we're shifting. We're going to pull out the R15 spray foam and just put an R15 back fiberglass, because they won't. All those two systems don't act the same. So again, always consider, always be mindful as an inspector what that compliance path is. And when we think about our conversations up to date, when we talk about those building thermal envelopes, we always talk about the 4 concepts of envelope location, envelope insulation, fenestrations, and air leakage. Well, now we're finally talking about air leakage controls. And when we take that air leakage control, like we talked about before, we really layer on those additional 4 concepts, right? What's the location? What's the material? What's the penetration response? And how are we testing it? Right? So when we think about, again, the location of our air barrier, we ask that very simple question: where is the air barrier? Right? Not where's the beef, where's the air barrier? And so when we think about that air barrier, that obviously the code gives us more than just a little bit direction. It tells us that we need to have that depiction. So we need to see on those details, on that construction document somewhere, either a depiction of that air barrier location. Because if I don't know where I'm looking, that's going to make my life in that project even more problematic, right? If this design incorporated, if let's say this was a completely heated, air conditioned and cooled garage area, then that thermal envelope, that air barrier, extends all the way out here. I need to know that, right? If it's going to separate between the garages, I know there are certain expectations associated with it. If this is if this is a 3-season room, where is the role, the relationship, right? We need to have these details on the paper so I know where to go And so when I'm looking at where are those air barriers, I understand I'm separating out conditioned from semi-heated space. I've got a ventilated attic in an unconditioned crawl space or basement area, right? What am I actually expecting to accomplish? And so if this is ventilated and I have uncontrolled air movement going through this attic or this crawl space, then I'm not going to install an air barrier there because it's uncontrolled airflow, right? We've intentionally designed it not to have those vents. I think I've told you before, I've got all kinds of projects where we go out and do the inspection and they install the vapor retarder, they install the air barrier, and then they put a vent right through it. It's like, well, you understand, we're now going to have uncontrolled airflow. It's like, well, what do you mean? That's good. That's where we said to put it. Well, no, that was when this was a unvented crawl space. It changes from a vented crawl space, right? So it's important we understand what is going on so we can make sure we apply the appropriate barriers in the appropriate places. That also becomes an issue when we think about those fuel burning appliances, right? If we have a fuel burning appliance in the middle of the room, basically like my home, right? It has a combustion air duct that brings in outdoor combustion air into the space, right? At all times. So when the furnace is not running, there is an amount of combustion air coming from the outside into the conditioned space inside that room. So I need to properly isolate that space so that I don't have uncontrolled heat loss. You can imagine if this doesn't have the appropriate doors, right? I would just get constant getting air movement, that cold air or moving in or that hot air moving out, one of the way or the other, right? Depending on which way we're trying to move which way the pressure is differential goes, right? So again, knowing those locations helps me identify what's the appropriate type of barrier, because I don't want it to be 70 degrees inside the house. This room's 30 because it's pulling outdoor winter air, and then I have condensation building up inside it. That then makes it into my interior framing areas, framing assemblies, which then create mold and mildew and all the other deteriorating impacts on that building. So again, we need to think about these things in our design. And as an inspector, I need to know where it is so I can make sure that we build safe and sustainable housing. Again, the same thing applies when we're looking at large scale multifamily, right? Remember, the residential provisions of the energy code apply to our 2, 3, and 4 occupancies, 3 stories and less above grade. So whether we're talking a hotel, a motel, or again, an apartment building, the residential provisions still apply. And so I need to know where that air barrier is. And is it part of this? Where is it in this assembly? Is it between floors? Is it, not, what are we doing? How are we going to evaluate where is it? But not only where is it, but what is it, right? When we start talking about the actual notes associated with it, what is it going to be doing? How is it going to be accomplished? These are questions we need to understand, because not every barrier is the same, right? In this situation, we see air barriers, and down here we talk about vapor barriers, vapor retarders. And so we need to start thinking about what are they trying to accomplish. Now we know that a water resistant barrier is trying to prevent water infiltration from the exterior environment into our exterior wall assembly, right? 50, 70 now, 70 years ago, that was new technology. If you think about it, the concept of using felt paper as a barrier between the exterior sheathing, and the exterior siding was new. We used to just have wood siding, right? And then we painted it, or we used a different type. We might have used a cedar shake or something that was weather resistant. And so as time progressed and we started adding maybe more cementitious materials, right? We started to add that vapor retarder because we knew that certain types of material, concrete, stucco, cement boards, right? When they get wet, they'll hold that moisture and it'll slowly permeate and pass to our exterior cladding, exterior sheathing. And so we started to install these water resistant barriers to resist the transfer of water between the two, right? Like I said, at one time, felt paper was new, right? Now it's like Well, that's the old way of doing it. Now we've moved to polyplastics, right? We've moved to house wraps, like we see here from DuPont, right? We see these things start to shift over time. And part of that is normal, right? We understand that happens. And so the code starts to identify these things, right? We move from that concept of resisting water to, well, it's not just water, it's also vapor, right? So we create vapor barrier, vapor retarder classes, right? Even in the 50s and 70s, we understood that what we needed to do was resist vapor transfer, right? That it wasn't just when it rains, it's also when it's hot and humid that we need to control these types of things. Or that when we have vapor inside the building, we don't want, a bunch of crazy Harmon kids running around creating so much vapor that it tries to migrate into the wall assemblies. And so we create these concepts of vapor retarders. One of the things that we see in new, again, this is constantly changing, which is why we have changes in the code. But in the 2024 International Residential Code, we see the introduction. Right now, if we look at the 21, we've got vapor permeable and vapor retarder classes, right? We understand those things exist. But there are technologies that allow us to have what we call the smart vapor retarder, right? That smart vapor retarder is actually a responsive vapor retarder, and it's identified and defined in the 24 residential code, right? So the smart vapor retarder gets its way into this code conversation. So again, we start to see that there's a variety of different things going on in a building, and so we need to make sure that we think about them in that long-term design. And as an inspector, I need to know what I'm looking for. Where am I looking for? What am I looking for? When we think about, again, that this type of material might be used as we know that this is craft face fiberglass insulation, and that craft facing, that paper facing, acts as a class 2 vapor retardant, right? And we need to know when it's properly installed, right? That if it's properly installed, we won't have these tears, and it will cover this, protect this exposed wood member, and we won't have these pockets and holes where vapor and moisture are just going to permeate through and then do exactly what we've been trying to protect against, impact the structural stability of the building. But that also means that we're thinking about the air barriers, right? So not only do we control for water and vapor, but also just general air movement, because we know air will carry with it conditioned space, right? That's why we have forced air furnaces, because we're shooting hot air across the building in order to temper and condition our spaces. And so we need to understand which materials might be being utilized in order to perform that function of air control, right? Because we're trying to restrict and prevent air movement through a building. And so when are we looking for water resistive barriers versus air barriers? And when do we find materials that might do the same? Because it's really a question of what are those barriers really trying to accomplish, right? We know insulation is trying to resist heat transfer, heat conduction through a material, but it's not always resisting airflow, right? We know that certain vapor retarders are trying to resist vapor intrusion, but there's also vapor responsive, materials that actually will allow for vapor to move through it on purpose to dry out, or allow an assembly to dry out. So we may have something that allows for vapor diffusion out and restricts water intrusion in, right? So again, thinking about these materials is going to be critical, and thinking about how they change in the future is going to be a part of that's the fun and beauty of code enforcement, right? So again, that water resistant barrier is really trying to resist or create for us a system. Now, when we have a lot of stucco and a lot of masonry, we're trying to create that drainage plane, right? That allows us we recognize that water is going to start to move, and we want to stop it, restrict it, and resist it, and redirect it, right? So again, thinking about how those systems get built really allows us to think, what is the best way to address the needs of the building, right? And then we understand that water resistant construction control is different than vapor diffusion control, right? That's when we start talking about, not only is this, maybe change the dynamic as an inspector. When I see an outlet or receptacle with this much uh, uncontrolled air movement or vapor space, vapor allowance, vapor allowing spaces, that's when I'm going to come in and say, oh, we need to seal this. What does the code say? What does the plan say? Well, we need to seal this because we're going to have uncontrolled air movement. This is going to allow vapor. This is going to allow more than just vapor, right? If you've been in a house post construction, like a post occupancy house, this is going to allow more than just air to move. We're going to see critters and little vectors, as I like to call them, as the code calls them, start to move in and out of around a space like this, right? Because again, we don't control the environment, and we know one thing about code is we want to control the environment. And so again, thinking about those different classes of vapor retarders really can impact what we choose to use, right? Are we going to be using a, again, to think about the classes of vapor retarders, are we going to use a poly sheet? Or are we going to be using some type of a paint? Because again, we're trying to restrict and allow for vapor control while also thinking about how do we prevent airflow. And part of that is understanding that not all, now when we think about generally, let me go here. Generally, when we think about the relationship between the energy code and these types of conversations, we usually think about our insulation, right? We usually think insulation, air barriers are the same thing. They're one and the same. No, they have a relationship and they may sometimes operate the same, be the same material, but that's not, we can't say every insulation is an air barrier because not all insulation is created equal. Right? If we're using a certain types of closed cell spray foam versus open cell spray foam, different depths and thicknesses, different air permeability rates, then we can start to identify different materials. If we're using a rigid foam versus a cellulose, those are going to have different both thermal conduction rates and air permeability rates. And we have to understand that not just because not only are insulation's different, but the method of installation of these insulating and air barrier control materials may be different, right? Just because we allow, again, that level of flexibility and prescriptive compliance doesn't mean that we can just say, well, just replace it with whatever you want, right? We need to make sure we follow those manufacturers' expectations on the proper method of installation. And when we think about it in a more direct review of the code says that we have to build this envelope to restrict air leakage, right? And that gives us these 5 sections of things to think about that we see identified here. And that starts with this understanding. To me, it starts with this, it begins to unravel this concept that we're really talking about the proper design, the proper installation, and the proper verification. Right, the code gives us, if we look at that list again, some additional things to consider as far as the relationship with fireplaces, fenestration, fuel burning appliances, and recessed lighting. But when we really look at it as a whole, what the code tells us is that we need to have details on how these materials are designed. Right, we need to know what is the expectation for this building. As a plans examiner, I go through this process to verify code compliance. As a designer, it's identified. Now it's my job as an inspector to go out there and verify that when it's installed in accordance with the manufacturer's installation requirements and in compliance with the requirements of table 402.411. Right, that's our air barrier installation criteria. Right, I used to try and say air barrier installation instructions, and that just I got tongue tied too often, right? And so again, the code starts to provide us these ideas. Now, these ideas and these concepts are not unique to residential construction. The concept that we're talking about, I always like to remind us that we start to see identified and laid out this idea of what we're inspecting for is a skill set that we use both in residential and commercial. It's laid out differently in the code. Here we see it as a table, and in the commercial we see it as a series of different subpoints. So again, we start to think about these systems and how they're going to operate. And we see over time that our understanding of the role and the components generally associated with our air barrier changes a little slightly. Again, we've talked about this. the code is at this point, we've understood, what we're trying to accomplish, right? We understand the purpose behind the energy code. Now the future generations, the future iterations and additions are really trying to refine, right? We're trying to fine tune our understanding of how do buildings operate. There is a place, and we've talked about this before. If you look at the 24, if we were to look at the insulation value, right, because that's usually what people think about. Insulation has gone up and increased in our expectation of the amount of insulation over time. But if we really look at the 21 versus the 24, there's a recognition that the number went too high and it comes back down because it's less about what's in the wall versus how well it's put in the wall. And it's really about the equipment that operates to make sure it operates its most efficiently. To have R30 in the wall and still allow for air movement really doesn't make any sense from a building perspective. And so that's why we see those changes in the code over time, right? And so we see certain items added to that list. And so again, we're asking that question: what are the barriers, right? Where are they? What are they? And we start to see them identified, right? We start to see things come out, and maybe as part of our assembly, they're using some type of masonry construction. And so we start to identify what is the air permeability rate of that masonry design, right? Where are those plans identifying things like air barriers and different vapor retarders? How much definition are we getting? Because again, this is that conversation, that relationship between plan review and inspections. I need things on the plan so where I get out on the field, I can quickly review the plan and do my inspection. I generally sit in the truck for a few minutes when I get to a job site and remind myself, what am I here to do? Right? If I'm doing an exterior wall inspection, that I'm looking to see before we put up the veneer, before we put up some exterior cladding. Okay, where's the sheathing? Is this sheathing supposed to be taped? Is this sheathing supposed to be sealed? Is this part of it? Is this part of the air barrier? Is this part of a water resistant barrier? What am I expecting out of this building before I get out of the truck? And so I'm expecting that information on the plan. Now, as a one-man shop in the county, that's what I would do. I would make sure that when I look at a plan for plan review, it's not going to be adequate so that when I show up later, 2 months from now, to do my inspection, am I going to have all the information I need? Right? Because as many of you, especially those of us that work in smaller jurisdictions or maybe don't work and have to do more than one thing, we understand that I have to plan, review, inspect the entire process. And I don't have time. My brain is not big enough anymore to remember everything. It needs to be on plate. It needs to be on paper. It needs to be on paper. And so that's where I expect and want to see that identification of not only where it's at, but what is going to be on that job site. Now, one thing I want to remind us of is the relationship that exists between the commercial and the residential. Now, in the commercial, they've provided a list. Now, we can always go to the ASHRAE Book of Fundamentals for residential construction and see the exact same thing, right? But if we go to section C402.513, in the commercial provisions of the energy code, we see materials, certain qualities of materials identified when it comes to air permeability. If we think about the air barrier in commercial construction, to me, it always makes sense in residential. Now, we identify there are certain types of materials that are pushing towards this air permeability rate of 0.004 CFMs per square foot, right? The code provides us a list of 16 different materials that provide us these different qualities that can be used as part of an air barrier when those joints are sealed and they're installed as air barriers in accordance with the manufacturer's installation instructions, right? Those materials we see listed generally here, right? So there you can see where we have EPS or EFIS systems that are full face polyiso. We see closed cell spray foam at 1 inch. The thing I want to point out is the density, the size of the material, right? There are certain minimum expectations about the depth of the material, and we need to make sure those are being applied, right? We need at least an inch of closed cell. Throwing it on real quick and saying, oh, we've done an inch of open cell is not the same as an inch of closed cell because they have different densities, right? You just can't throw out any OSB board. It's got to be at least a 3/8 inch, right? Now, is that going to be typical and common? Maybe. But again, we want to make sure that what we're getting, right, is not a 1/4 inch. We're getting a 3/8 inch because it's easy for people to say, we threw it up there, it's fine, right? What we're looking for is that this material has been tested, has been determined to provide that level of air permeability protection that we're looking for in an air barrier. But again, it's not just throwing up OSB and saying we're done. It's properly sealing the joints and connections between those materials, right? The same thing with, just throwing up some rigid insulation is not the end of the day, right? We need to make sure that we properly install it, that we've, again, properly sealed it. And we see, again, the different materials identified. But it's not just individual materials. The code also gives us some assemblies, right? And it gives us 3 of those as far as masonry walls and different stucco, different exterior finishes and assemblies that, again, have to meet certain expectations, right? We don't just say any concrete wall, right? Because most of us have seen concrete walls, and over time, they'll allow for moisture movement. It has to be concrete wall that's either got a block filler or applied with a paint or sealer, right? It sounds like, oh, well, yeah, we would do that. Well, you know how many times oh, yeah, we would do that gets missed? That's the role of the inspector, where you didn't pay, you didn't seal it. We forgot. Again, I've had projects that I've been called on where it's been, they didn't install it right. So we're going to rip out the foundation, rip out all that backfill and refill. There was a conversation in one of our code development meetings on Tuesday where we talked about the relationship. We install all this, great, but when we backfill it, they just backfill it and throw everything up against it, compress it, damage it, and then we get moisture accumulation. Well, yeah, because it wasn't done right. The code doesn't say backfill with any rocky material you want. You backfill with good, clean soil so that you maintain control over that environment, over that assembly as it sits in the ground. So again, there are assemblies that might be utilized to demonstrate it. So again, it's a question of of not only what's in the code and how are we expecting to happen, but what's on the plans, right? Making sure that these details are lined out. If I show up to a site and I see that they're applying, some OSB 7, now this is 7/16, right? So I see it's the right size material, and I see that it's identifying we have to have this taped layer, then again, I understand what I'm expecting to see. As an inspector, I'm looking for tape. If I go on there and there's no tape, then we're not performing the way it was designed, right? If I use this example here, again, as another way to say, there are certain sequences of installation, right? We expect, it's almost comical, but we would expect the exterior veneer before on the outside of the rigid insulation, right? Because we expect that kind of a sequence of design. If I go to, Jimmy John's or Jersey Mike's or Five Guys or Firehouse Subs, anywhere that's got a good sub, I understand that I'm expecting to have the bread on the outside and the meat and the cheese and the lettuce and the sauce on the inside. If I went there once and it was flipped around, I would know the difference, right? But there are certain things that just we need to make sure that are just following the proper sequence. And once in a while, we want to make sure that we're installing them in the right sequence, the right exterior leading edge of the right material, or else we're going to have the sandwich going to be made wrong. It's not going to perform the way it's designed, right? We can go to our designs and we can see where we've called for, again, both vapor retarder above the granular fill, below the concrete slab, right? We understand what we're trying to accomplish there is prevent moisture accumulation from moving up and then getting in direct contact with our slab. We also see the air barrier, air infiltration barrier over the sheathing with specifications, right? So we have an understanding of where it's supposed to be in the relationship and that there are additional details. We see that further identified yet again, right? We see air barrier over the sheathing. Well, air barrier over the sheathing, We see the veneer. We see the layout of all these different components, what we're supposed to seal or something. So again, we know what we're looking for in that design. as an inspector, this is what I'm looking for. When I show up, I know I should be looking at an interior wall, insulation, exterior sheathing, a layer of, where's it at? There it is. So I should have my exterior sheathing. I should then have my air barrier behind a layer of polyiso, continuous insulation, upon which there's then going to be another air barrier over that. And then we're going to have, again, our veneer, right? I'm looking for all of those components because what I want to make sure is that building's going to have everything it's supposed to have to protect it from moisture, either penetrating through this veneer and then soaking up into this polyiso, or coming from the exterior, right? We want to provide those different layers of protection. But it's not only what's on the plan, it's also what's in the spec book, right? Proper installation, proper instruction. And so again, we have to know how are those barriers being installed and how are they demonstrating compliance. One thing I once in a while will ask a contractors, especially the first time I've seen them, how did you install this? Right? If I'm watching them install something, how'd you install this? How'd you install it? Well, I just put it together. No. Was there a specification? Did you have an instruction manual? Where is that? Oh, well, yeah, no, this is just how I do it. No, I need to know what's the proper method of installation. Now, sometimes it's easy. Sometimes you know what to do, but sometimes you want to clarify, right? And that's the role of the inspector, to verify that the building is being built properly and in compliance with those plans and those specifications and what the code says. Now, one of the things that we talk about once in a while, especially with insulation, and when we talk about this in relationship with air barriers, is I like to think about the code tells us we need to identify, right, the materials and the different systems that are going to be part of the building. And we normally think about that as, okay, did you mark it with the R19, the R13, whatever that insulation value is. But more importantly, we also need to know that what you're installing is the appropriate air barrier, vapor barrier, or moisture control layer, right? Those are the things that we're trying to identify. And we need to make sure that, again, they follow the IRC and the method of the manufacturer's installation requirements. Because sometimes we're going to have different materials performing different functions, right? We may have a bath that's got the craft face to provide that. We want to make sure it's on the right side, the interior side of the wall system. We may have a design that calls for a clear airspace, right, as part of that. So we have vapor control layers and air control layers, and they aren't always the same. And so we want to make sure we think about how are those systems going to be installed. Now, that always takes me to the question of how do we verify? And that's where, again, we tried to lay out this field guide, because it's not only just a quick yes, it looks right, but how do we really take that deeper dive? And so one of the ways that I use this, or tend to use this as an inspector, was I would take time. Now, again, I when I worked for the county, it was me and only me, and I had some assistants once in a while. And so what I would do is I would actually use a very similar barrier field guide, and this is how I would track all my inspections or track my projects. And so I would put on there the approved plan, the approved plan page number, where I see the wall details, where I see the door and windows, where I see if we're having cantilever floors, or where's that location of the air barrier. So that's why I usually use this form, right? Where's the approved plan page? Then when I went out and did my inspection, did I verify it, or do I need to follow up? Do I need to come back, right? This is my way of tracking, because this is not a one-time inspection. This is an inspection that takes place over a course of several visits to the project, right? And so it's not only saying, where do I see it? But again, going out and verifying that what I'm expecting to find is what I find on site. And so again, we see some of these things identified. We understand that part of that expectation is the continuity of the air barrier. We don't want to see breaks and changes in that breaks along that design. There are certain types of material that are appropriate for different uses. Just stuffing a door with bad insulation is not sealing that door, right? So making sure not only do we have continuity, but we have the appropriate materials being applied, right? When we think about ceilings, we understand that we could all run through this process together, right? We know that when we're looking at ceilings, we want to make sure that we have continuous contact, that we provide appropriate uh, sealants along different areas. We also know about the access panels, right? Things that we need to think about in those designs that we're looking for. You know, how are we properly installing those attic accesses and making sure that, again, if we have spray or not spray, blown insulation around, you know, maybe a sloped roof systems, ceiling systems, that we're actually putting in the appropriate baffles to hold it in place, right? We think about those walls, right? We're thinking about the relationship between the different junction points, right? Between our seal plates and our bottom plates, and how are we controlling for air movement? We've all seen those gaps, right? We know that it moves. And so we need to think about those kinds of things. Or again, if we're looking at top plates, what are we thinking about? If we're sealing over headers, right? Where are we need to look for all these spaces where air might move. Now, you guys know I've used I don't know where it's at. It might be, I think it's my back. We've used those thermal cameras to, again, identify areas. This is one of those times where I'll be looking around and just, you know, I know where I'm looking. I know what I'm looking for as far as sealing. And if I don't see sealing in certain areas, I'm going to pull out my thermal and I'm going to, hey, we got some air movement still down here. We got some temperature differences that exist. So again, those are great ways to look at it. And when we think about, again, our windows, applying the appropriate type of insulation, it's not going to be expanding foam, right? We know that. And so what are we going to do? And if we look at certain types of installations, and that again is part of that narrow cavities consideration that we see in table 402.411. Some more just examples that we're looking at is maybe some of those cantilever floors and rim joists, right? Where we're starting to protect against infiltration. We see our basements, our crawl spaces. What are we expecting to accomplish, right? Again, this fiberglass bat insulation that's not protected against moisture intrusion is not going to be long-term successful, right? What we know is going to happen in that basement is it's going to get wet, it's going to get dirty, and it's going to get mold growth developing on it, right? And not only that, how are we thinking about the moisture that accumulates behind these systems? I had a project, a friend of mine, they ended up having to redig out their basement, their crawl space, to reapply additional sealer on the exterior wall because they were getting so much moisture. And then they need to install some other moisture reduction measures, moisture control measures, to again get that water to drain away from the exterior wall. When we have these areas of separation between some of these spaces, we start to see, you know, in a garage space, or again, if this is again maybe a separation between a vented crawl space and an occupied basement area, or as in my home, a tri-level, right? If we don't have adequate control for that airflow, for that moisture accumulation, then we're going to have areas of moisture contamination and condensation. And so again, it's verifying taping, verifying the appropriate barriers are in place for the design. Again, looking at recessed lighting and plumbing, different fixtures that we see, the different components, making sure that we're not only properly installing and thinking about things like compression, but we're also thinking about penetrations associated with these designs, with these different materials. Like we said, in bathtubs, showers, against exterior walls, because what we're trying to do is, again, protect against the condensation that will occur and begin to in this space, and then have direct access to the exterior wall, right? So we want to prevent condensation from accumulating in these hidden spaces. Same thing with our control box, our electrical boxes, right? Like we said earlier, we want to make sure that we're protecting this area so we don't have infill and exfiltration of air, but also other contaminants. And again, like I said earlier, we want to look very quickly at some penetration details, making sure those are identified in the plans and making sure we have a method for understanding what it is we're going to be doing and what we're going to be expecting to find when we inspect a property, right? This felt tar paper looks like it's great as a water resistant barrier, but it's not sealed or taped to perform as an air barrier. So that means there needs to be a secondary layer for air control. This is not the only layer of control, right? We've talked about, again, the penetrations of different conduits, condensation lines, different pipelines. And so we want to make sure that we're protecting against, again, air filtration, water filtration, vapor. Vapor and water are not my only concern about this hole, right? I'm seeing some critters walk right through there. Same issue here, right? We know what happens over time, especially in certain rural areas, is you're going to have access to certain extra animals and critters who will look for places in cold weather or in inclement weather to hide, run, and hide to run to. And so again, how are we sealing this? As an inspector, what am I expecting to do or to find as my response? Right? I see they've taped it, but now we're not sealing. Right? And so are we supposed to tape this? And is that tape going to be this? You know, I don't work for 3M, so I'm not suggesting everything has to have tape. I'm making sure that everything has the appropriate sealant, right? This is not the appropriate sealant for sealing this penetration. But then we also have to understand there might be designs, especially when we start talking about barn dominiums, right? We start talking about some unique designs for residential construction. You may have different control layers being utilized in different ways. And so we want to make sure that if we have a penetration, again, of a control layer or some other structural feature in contact, right? We see a little bit of that tape flashing here, the tape there to in that transition space between the steel that we don't see here, right? What are we trying to accomplish? We're trying to seal and prevent airflow, right? We're trying to seal. Now, if this was my kid, if he laid that piece of OSB there, I guarantee that's ripped right now, right? And so we need to think about how are we protecting these systems in reality. And then again, not making those assumptions, but what method of installation or adherence, right? What type of adhesive are we using? Are we using a tape? Are we using some type of adhesive behind this to make sure that we have proper and constant contact to prevent airflow between these materials? Liberally applying the caulk that we might, or sealants that we might be using, right? Versus this, right? This is definitely not applied adequate enough to present pressure differences and changes, because we're starting to see here already those holes starting to open up where moisture and air are going to get through. As well as, you know, if again, we said this CMU wall properly installed is my air barrier, but then I poke a hole right through it. So when I'm doing my mechanical inspections, when I'm looking at maybe my plumbing inspector needs to know, hey, when you see this kind of thing, make sure it gets sealed. Make sure we're thinking about the entirety of the process. I used to have that conversation. Where in my former last department, our plumbing inspections all come from our health department. So I had to have those conversations with my plumbing inspector to say, hey, when you see these things, take a second to identify them. We're in this together, and we want this building to work effectively, right? There are going to be light fixtures, and there are going to be other things that come into contact with insulation and that need to be properly sealed, because otherwise we're going to have uncontrolled airflow around them. And we also know that once in a while that fire blocking and draft stopping are critical components of fire safety, and they're also an opportunity for us to, again, protect against uncontrolled airflow. If we can stop the air, we can stop the smoke from moving from assemblies to assemblies, right? If we're protecting it against fire, we're protecting fire embers and fire transfer through in a wall assembly, then we're going to be protecting it against air movement. So again, we can have systems and materials that might provide complementary controls, right? And that find ways to address concepts of pressure differences, right? That get into those concepts and those conversations. If we're looking at a multifamily building that's got a fire escape area, and we want to make sure that we think about, you know, how are we protecting against uncontrolled airflow from an exterior exit space, right? If there's a basement, a first floor door down here that's just open and ajar, we're going to fill this semi or unheated space with cold air, and then that's without the proper sealant, that's going to start to affect the surrounding occupied areas. And again, we see another example there where we want to properly seal something. We've talked about these before. The relationship between the different trades are critical to understanding not only good construction practice. We'll be honest, there's a whole lot of things that are going in our head about this situation here, but also to make sure that if that was the appropriate design, which I guarantee it's not, now how are we sealing this design? And when we have a building, I know it's not always the situation in residential, but sometimes we need to think about high wind areas. And if we were filling a multifamily structure and we were trying to, and we had some inappropriate or errors in our penetration layout, and we've got these holes now that need to be filled in, what's the appropriate response? If I'm in a space, if I'm out on the hills, down, I'm going to pick on Pampa because I don't see them on today. I don't see Carry On. But if I'm in Pampa and I've got some strong winds coming in, is just a little bit of Tyvek going to be enough to maintain positive and negative pressures associated with this design? Or am I going to have a failure, right? And I don't want those failures. I want to protect against it. So maybe having appropriate designs that think about the straight line wind effect, the wind speeds that are going to go into a design, and making sure as a building inspector, I'm looking for those, right? That I'm looking for, different considerations like the type of material being installed, properly taping along different framing connections or interconnections, and not just allowing it to be some, rolled on, improperly applied, right? If you read the manufacturer's installation instructions, this is not the appropriate way to install this. This needs to be rolled flat. You can still roll it and get it accomplished, right? But you need to actually make sure that we don't have air pockets and especially unaddressed air pockets where we're having constant air movement. Because we know if that gets into that assembly, that chase this tower area, then that's going to, again, just be uncontrolled air movement, which will cause condensation accumulation. Because we know certain materials can be installed as air barriers, as water resistant barriers, air barriers, and as fire resistance components. And so we need to make sure that we're following the appropriate technical guidance on which systems can do what. And if we looked at DensGlass, DensGlass is a material used for fire resistance, but its permeance level is higher than what we would allow for air leakage controls. And so what we look and find out is that they have additional expectations, additional materials that get applied, flexible sheet materials that get applied to provide that level of water and air resistance. And so we need to make sure it's properly installed, and we don't just say, hey, I see it. It worked over in some other town and it should work here, right? Just because it works in Dumas doesn't mean it's going to work in Amarillo. We got to just because we see it, we need to make sure it's properly installed, that we properly, again, sealed it versus just installed it. Now, all of that is there to support this idea that we're going to have testing associated with the design. We'll talk more about testing in 2 weeks, but ultimately what it really breaks down to is, again, understanding why we're looking at air barriers and how they're supposed to function. So I know we went through that kind of quick, and I apologize. We don't have a whole lot of time for questions, but if you have questions, obviously we'll stick around. Next week, we're going to talk about exterior lighting. Now, that's not a huge thing for residential, but we'll look at it more from the multifamily side of things. And then we'll get into that testing, and then get back into fenestrations. Res check will be a conversation on the 17th. So I'm looking forward to that. And then we'll get into mechanical design and different considerations. Got some new resources I'm trying to get squared away before we get to that. But again, remember, use your survey if you have any questions. Put it in your calendar now. We're going to have our in-person training on Wednesday the 9th. We're going to square up a little bit more of the what we're going to talk about. But we're going to be at the Sims building downtown in Amarillo. I think it's room 275. But I will get that once we get a topic. I'll send out an email to everybody getting you a heads up again. But mark your calendar now to show up on Wednesday the 9th in the morning for that training. I'm thinking it's in the morning, but we'll confirm all that in a letter later. Remember, if you have any questions along the way, feel free to send out this information to anybody. The TX helpline at Shums Coda gives us an opportunity for different people to send in emails, questions, or that we can help with. Anything related to the energy code or the standards, we're here to help you guys out. And again, if there's anything you guys have any questions about, feel free to reach out to us. Again, that TX helpline is a great resource because it goes to the entire team. So it goes to Hope, myself, Andre, Jim, Gil, the entire team while we have them all here. So if you have any questions, let me know. Otherwise, I'll see you guys next week.